All right, now let's start. So 3.3, I'm going to go on to next point in graphing these lines here. And we're finally actually starting to graph lines here. Last time in 3.2, remember we just plugged in points individually. That's kind of what we're going to be doing as well, and then we're just going to connect them. This is by far the slowest way of graphing. And what we want to do is we want to increase our speed really in graphing. So if you had to do it this way, you can always graph by just individual points. That's no problem. There's something called the intercept method. It's going to be a little bit faster. And there's something called the y equals mx plus b. A little bit faster. We good? So it's more of just increasing rate, not so much as you can't do it by those methods. All right, so here we go. We're going to graph 2x plus 3y equals 6. Dun, da, da, da. We're going to make ourselves a little table. Now, it does not matter which number to plug in whatsoever. You guys get to decide. And then also, it doesn't matter if you want to plug in for the x or the y. Because if you plug in for the x and solve, you get out the y. If you plug in for the y and solve, you get the x. So it doesn't matter which one you use. So, easiest number to plug in? Obviously, 0. All right, so then let's put also a 0 in for the y later, just so we have it all ready to go. And then I'm going to choose, again, we could plug in whatever we want, right? I'm going to choose a 4 for the y. You guys could choose a 2 for the x. Someone could choose a -1 for the y. It doesn't matter, just any other point whatsoever. Cool. All right, so really what we're doing is if we're connecting it back to 3.2, we're just doing this from 3.2. And remember, hopefully that you saw that in the homework there. It's just we're filling in the blanks. A 0 for the x causes what for the y? A 0 in for the y causes what for the x? And a 4 for the y causes what for the x? Anyways, plug it in the 0 for the x, da-da-da, and I heard a 2 already. Y equals 2, so 0 for the x gives me a 2 for the y. Cool. Plug it in the other way here. How about a 0 in for the y? Let's see. Perfect. Yep. That'd be 3 there. And then last one, whatever number you want. Again, 4 for y if you want to do it like me. Any other number, x or y if you want to do it yourself.
It's -3, isn't it?
I think so, yep. So 3 times 4 is 12. If you subtract 12 from both sides, it gives you a -6 this time. Divide by 2, and you get yourself a -3. Cool. Let's plot them. So 0, 2 means 0 sideways, 2 up. 3, 0 means 3 to the right, and then 0 up or down. -3, 4, so that means, hold on, so 1, 2, 3. 3 to the left, 4 up. And again, all those, remember that little word from high school geometry, something called collinear, right? They should line up in a straight line. And if they do, that means most likely you are correct. All right, put a line through them. Don't forget to put arrows on both sides. Arrows both sides means it keeps on going. Okay, and again, we're going from slower to faster and faster. Okay. Next one, and you can notice a few things here. Notice if you have the x and the y on the same side, you sort of have to do some algebra here, right? You plug in, you solve. A little bit faster time is had when you have something like this. Y is equal to 2x minus 1. If you have the y that's already solved for, you don't need to do any algebra. Love it. So at this point, we're going to plug in for the x only. Because if I plug in for y, then I'm going to have to solve for the x. No, I don't want to do that. So, easiest number to plug in again?
0.
Awesome. And if I plug in a 0, what do I get? -1. Cool. Okay, at this point, all yours. Go for it. Whatever 2 other numbers you want to plug in for x. And hopefully you can just do it in your head. And again, your numbers are going to be different from my numbers. And your numbers are also going to be different from the book numbers as well. So kind of be mindful. Whenever you're graphing, you're not trying to make the points to be the same as the book. You're trying to make the line to be the same. All right, I'm going to plug in a 3. So 3 times 2 is 6, minus 1 is a 5. And then the other number I plugged in was a -1, just for the fun of it. And that gave me a -3. So your line, my line should be the same no matter what points we used. So 0 sideways, 1 down. So that means we go 0 sideways, and then we're going to go down 1. 3, 5 would be up there. -1, -3 down there, and yeah, they look like they line up. Yep, cool. Line straight across and done. Now what the book also does, it actually writes the equation. It'll say y is equal to 2x minus 1 right next to this little line right here. You don't need to do that. The only time that you really need to do that is if you're graphing more than one line on the same axes. That's when. And you're trying to distinguish between the two lines. Otherwise, it's good. Okay, Jessica, yours is different than mine.
Huh?
Yours is different from mine. First point is different.
No, it's the same. And then I also put a 3, and you also put a 3.
Uh-huh.
And then the bottom one I put a 2.
Check out the first point, though. First point is right here.
Oh.
Because you're going to go 0 sideways.
Oh, was I supposed to do exactly what you did? I thought we could just put our own numbers.
No. Since you have 0, 1,
Mm-hmm.
right? That means your point should be the same as my point. So 0 sideways, 1 down.
Oh, duh.
The
I
x
put it on the
controls,
X.
yep.
Yeah. Okay.
X controls the sideways position, and y
So it should have
controls
been
the
down there.
vertical. Okay, the only time that you want to think about the numbers you plug in is if you don't want to work with fractions. So the next one talks about that. Notice you have a -1/4. Again, making my little table, x and y. And again, the easiest number to plug in is still 0.
1.
Perfect. All right, you should also notice this connection as well. If this whole thing becomes a 0, the answer for plugging in 0 is always going to be this number at the end. Right, because this whole thing disappears anyways because of the 0. Now we've got to deal with this fraction. So if I plug in a +1 into here, then I'm going to get a -1/4, then I'm going to have to add it with 1. It's not something I want to do. So let's do this here. Let's get something that 4 will actually cancel. What do you guys say? A number that 4 would cancel. Hey, I know, 4. If I plug in a 4, let me do it real quickly here. -1/4 times 4, what's going to happen to the 4s? Yeah, absolutely, because you make that into a whole number there. And there's my 4s go away. So I don't have to deal with the fractions. We good? So that technically is a -1 + 1, or just a 0 on this end. Hey, we found the y-intercept. That's cool. Or the x-intercept. Okay. Okay. What's the other number I want to plug in? Should I plug in a 5?
8.
No 5, but 8 would be a good one, right? Because 4 would cancel off with the 8. The other one would probably be like a -4 or a -8. Any one of those 3 would work just fine. So I plug in -4. If you want to plug in a +8, that's fine. Either or is going to work. All right, plug in a -4. 1, 4 goes away, but there's still a -1 here, so that's a -1 times a -1 is a +1, and 1 + 1 is a 2. Alright, so my graph is 0 sideways, 1 up, 1, 2, 3, 4 to the right, and then stop, and then -4, and then up 2, and yeah, that looks collinear to me. So line through all that, and arrows at the ends. Okay, good. Next one, number 4, just a little bit more complicated. I'll let you guys try it though, and I'll just say sometimes you'll get fractions here, and that's okay. So I'll let you guys try it yourself here. Plug in whatever numbers you like. Alright, I'm going to begin as well here. So again, for me, the first number I'll probably plug in is 0 for the x. And when I do that, yep, and you get this little concept of negative 2 times y is equal to 3, so divide by negative 2, and you get yourself a negative 3 over 2, which at this point, because you're graphing, you actually need to know where it's at, right? 3 halves, I'm not sure what 3 halves is, so at this point you probably want to change it to a mixed number. So negative 3 halves technically is negative 1.5. So anytime you have improper fractions, you probably want to change them to a mixed number to see where you're graphing. Okay, 0 go in for the y value, that's pretty easy. That all disappears, so x equals 3. And then I plug it in a 2 for the x value. Again, you could have plugged in something totally different than me, that's okay too. This time you probably had to do a little bit of algebra to finish off the problem itself. So I got myself 3 minus 2 is a 1, divided through by negative 2, and so y equals a negative 1/2. So anybody that got a 2 or plugged in a 2, then you guys should get a negative 1/2.
I plugged in a 4 and got negative 1.5 too. Would that be right?
Should not be. Let's see. Alright, and with that, let's go graph it now. So again, your points could be different from mine. This is negative 1.5, which means negative 1, and then halfway to negative 2. 3, 0 would be about right here. 2 and negative 1/2, then that would be about right there. So yep, they all line up. That looks like a straight line coming across. So straight line coming across with the arrows, and we're good. Alright, so let's take a look at like 3 special lines here that we're going to have to go through. So first one, this one right here, just y equals x. Again, pretty needed later on in mathematics. A lot of application with this line here, but let's go for it. Just make a little table. 3 solutions all we need. But what does y equals x mean? It means that x and y are the same exact number. Alright, so if you plug in a 0 in for the x, 0 is the y value. Alright, and this is, later on we call it this an identity equation. Alright, if a 3 goes in for the x, there's a 3 for the y. Again, choosing numbers you like. Negative 2 for me. But as we graph it, 0, 0, 3, 3, negative 2, negative 2. It's this diagonal line that comes straight through the origin. Okay, your book calls this the line that goes through the origin. Alright, so one category of lines is the ones that go through the origin. Next one, of course I have to give you a fraction inside it. So notice we're trying to graph both x's and y's, but this time I just see an x. There's no y value here. Alright, my little problem is 3 halves. Do I know where that is exactly? Should I change it to a mixed number? I probably should change it to a mixed number. That'd be 1 and 1/2. Right? 2 goes into 3 once, with 1 left over. But at the same time, this equation, x is equal to 3 halves. What does that mean? Because there's no y whatsoever. There's no relationship between x and y. Well, a few things here. It means that x is always the same. X has to be a constant, and that constant is 1 1/2. Cool. At the same time, it also means y could be any number whatsoever. So there's no relationship between x and y, therefore I can put in any numbers. 0 would be a good one, but 4, 6, -3, 7, -2, whatever you want. Now, can you graph those 3 points? And see how they graph. Alright, so 1 1/2, 0, 1 1/2, 3, 1 1/2, -2, and voila. Cool. Anybody know the name of this little line right here? I don't know. I think it's a vertical line. Line that goes straight up and down. We call that a vertical line.
I'm sorry, I was thinking this is real fancy. But anyway.
A highly technical name, vertical line. Cool. All right, and then how about, let's go the other way. What happens if you just see a y and that's it? There's no x there.
Y will always be -1 and you can choose any number.
Whatever number you like, but y has to always stay -1. And then your choice for whatever you want x to be. So 0, -1. How about 3, -1, and -2, -1? I think almost everybody had that line drawn as well, right? So it's a little bit underneath the x-axis. All right, and the highly scientific name is horizontal line. All right, if you want to refer back to this just kind of quickly here on page 194, just whenever you need to, you can always go back. It's the line that goes to the origin, the vertical line, the horizontal line. There's a whole equation. So whenever you see y equals 4, you should recognize, like, oh, hold on, that's a horizontal line. Done. Or when it says x is equal to 3, you should recognize, oh, that's easy. That's a vertical line going straight up and down. All right, with that, let's jump to 3.4. So 3.3 taught us we can plug in points. We need about 3 of them or so. Any points we like. Graph those points. They should be collinear. Connect them with a straight line. Put arrows at the end. You're done. 3.4 tells us a little faster way, at least somewhat faster. Something called intercepts, or the intercept method. And really, we have been doing the intercept method already. We just need to recognize this right here. The one thing that's always common to all the points along the y-axis is they always have a x-coordinate of 0. We're good? So if this was here, this would be like 0, 2. This would be like 0, 4. This would be 0, 6. This would be 0, 8. Down here would be 0, -3. So if you always have an x-coordinate of 0, technically, if you plug in a 0 for the x variable, you're always going to wind up with the y-intercept. We good? Going the other way, if you plug in a 0 for the y variable, whatever number comes out, that would be where it crosses the x-axis. And we have been doing this anyways, so we'll just go through it here. So x minus 3y is equal to 9. How did we do this? And the book doesn't spend much time on it. And we can pretty much do it this way, right? We've got x and y. We've been doing it last section. We put a 0 in for the x right here. We put a 0 in for the y. And figure what comes out. Can we actually do this in our heads? If 0 goes in for the x, what would y have to be?
3. Or -3.
Negative 3. Cool. So then if 0 goes in for the y, what would x have to be?
9.
Everybody okay with 9? 0 goes in for that one, that's a 9. And again, if you're not quite sure, let me show it to you real quickly here. So if 0 goes in for the x, this disappears. So we're left with negative 3y is equal to 9. And again, if you think about what's the multiplier that multiplies negative 3 to give you a positive 9, it's negative 3. Going the other way, if 0 goes in for the y value, all this disappears. This guy, 0, 0, 0, so notice all that is going to go away. You're just left with x equals 9. So that's kind of cool. Okay, because once you have that done, you're done. Look at that. So the intercept method, plugging in zeros, hopefully you don't have to even write anything down. You can just plug it in and see what happens. So 0 sideways, 3 down. The only thing is here, notice this graph goes to 10. 1, 2, 3, 4, but there's only 5 lines here that gets us to 10. So that means each one of these lines is 2. So therefore this going to have to be negative 2, negative 3 is going to be right here. 9, 0 would mean the x-axis is 9. Perfect, and then I think I got the rest right here. Hopefully your line is more straight than mine. Alright, if I want to show you all the details. So you guys, number 2, try this. Negative 3x plus 2y is equal to 12. And again, not going to spend much time on this section because we've been doing it already anyways. I'm going to do it sort of the long way, the way the book does it here, just to show you here. They always put x-intercept and they put y equals 0, just to remind ourselves the connection here. And as the 0 goes in for the y, they sort of do the algebra behind it, but any which case, you should get negative 4 for the x, or negative 4, 0. If you got that, you're doing good. Going the other way, the y-intercept, we're going to plug a 0 in for the x. As the 0 goes in for the x, it's really 2y equals 12 or y equals 6. And there's the other point. No matter which way you do it, that first way where you make a quick table, or the second way here where you show all the steps, hopefully you guys got those 2 points there. Cool, alright. So notice we're not doing a third point. As long as we know did it correctly, we really don't need a third point. So negative 4, 0. And 0, 6. And connect with the straight straight line. Arrows at the end. Okay, where it gets a little bit more complicated. Notice it's really easy if the x's and y's are both on the same side. You can almost sort of guess at the answer. You can get the answer in your head here. Sometimes we do want to find the intercept, and it's drawn like this. Y is equal to 2/3 x plus 4. Still use a table, but you might have to do a little bit of algebra to solve for one of them. Alright, this one, again, make the table if you like. If you want to do the way the book does it, which is like this, you plug a 0 in for the y value. In this case, there's a little bit of algebra work here to be done. So how about we multiply through by 3 just to get rid of the fraction, so I'd have to think about it. So 3 everywhere. 3 times 0 is still 3, and then these 3 cancel off. Just 2x, but the 3 also has to distribute to the 4. This is distribution right here, so 12. And how about subtract 12 from both sides? Divide by 2. Everybody okay with x equals -6? That's going to be for the x-intercept. The y-intercept, that's the easy one. As the 0 goes in for the x value, the y becomes just 4. So hopefully you have those two numbers, whatever way you did it. But that first one here, getting the x-intercept, you had to do some algebra. Alright, so this is -6 is 0 there, and 0, 4 is there. Straight line. Arrows, and we're good. So again, as long as the line is the same. Okay, so let's think about this just for a little bit here. Let me go back. So this side, pretty easy to find the y-intercept, is that right? And the x-intercept? Going back even further, this one, pretty easy to find the x and the y-intercept? The reason for it is because x and y are both on the same side of the equal sign and just a constant term. This one is the one that we probably want to use a little different method because that took way too long. I have to actually write stuff down, and I don't like when I have to write stuff down to graph. Cool. Right, before we get there, we have to get to the concept of slope. What in the world is slope? Alright, slope of a line. And we can have negative slope. And the way we read this, we always read from left to right, just like you read a textbook along the x-axis. So I should be going this way. And you notice this we call a negative slope. If you think about walking up a hill or down a hill, this would be walking down a hill. So negative slope. There's also a 0 slope, which means if the line is not going up, not going down, so you're walking flat on the surface, your elevation is not going up or down. Positive slope means you're climbing the mountain, your elevation is going higher and higher. Whole bunch of applications to slope here. Whenever they make a building with a roof that's sort of wedged a little bit, like going up and down, and we call it a pitch, but they have to understand what slope is, how fast water is going to drain. Ever went on a highway and it said like a 2% grade or a 5% grade? That is a slope. That's how fast elevation is going down based upon 100 feet going horizontally. So slope is a lot of applications in slope. Alright, we want to get to is the algebra application here. And if you notice, what's really happening between these 2 points here is that we want to figure out what is the change in the vertical compared to the change on the horizontal. Like if you're going down the highway, if a 2% grade means how much change is a vertical happening compared to the horizontal. So we call it a rise over run, but the formula that we want to use is this right here. We want to use y2 minus y1 divided by x2 minus x1. Of course, everything makes sense in mathematics because the letter that we use for slope is m. Good? Of course it makes sense. No, the reason why the m is used is because slope was invented by the French mathematicians, and they always do everything bad. No, just kidding. Their word for slope started with an m, and so we just kept that same symbol in a sense for slope. So, okay, so got the formula down. Let's practice. And once we get this whole concept of slope down, then we can do the very, very easy, quick way of graphing lines. That's what we want to get to. So, just a quick view. How do we do slope? We're trying to figure out we're trying to figure out the steepness of this line. If a line graphs, one point is at 3, -2, the other point is -1, 7. What's the steepness of this line? And we're going to use this little formula. Now, before that, we're going to label this. And if you need to label it, go for it. So this we would say this is the x-coordinate of my first point. This is the y-coordinate of my first point. That's where those little letters and numbers come from. -1, that would be the x-coordinate, but now this is my second point. And the 7 would be the y-coordinate of my second point. And all we do is just follow the formula. M equals y2 minus y1, x2 minus x1. Of course, I do have a few little tricks here up my sleeve. Usually for Math 61 students, it's a whole bunch easier because you got negatives and positives here and all that stuff. Usually it's a lot easier to put in parentheses in place of the numbers you're going to plug in. So you kind of have 2 parentheses on top with a minus. 2 parentheses, 2 sets of parentheses with a minus on the bottom. At that point, it's a lot easier to sort of plug in values. So, what's my y2? 7 it is. What's my y1? -2. X2? And x1. Perfect. Okay, with this, that allows me to see this real quickly, right here. See how I'm subtracting a negative right here?
Plus.
You got it. Just from chapter 1, we're just going to add some plus signs here. So 7 plus 2 is a 9. This one, same thing. That means this is now going to be a -3, but we're adding them. -4?
Yeah.
Cool. Okay, I'm going to go back just a little bit here because I got a few people here looking at me like they just saw a ghost. So let's go for it here. Back to chapter 1 in our minds here. If you're subtracting a negative, it is the same thing as adding a positive. So if you switch the operation, you just take the opposite of this number here. So it's negative, it's a positive. And then you do the operation rules here, the addition rules. So 7 plus 2 is 9. The reason why I changed this one here is because I had a negative here. If this was a positive, let's say 15, 15 subtract 3, that's easy. But this whole concept, because it's a negative, I'm going to change this guy to an addition problem. What's opposite of 3? -3. At that point, now I'm going to use addition rules from chapter 1. -4. Alright, here's the only thing is, we don't like to have negatives on the bottom of fractions. So we either put the negative on top, or we put the negative in front. Whoops, sorry. Of our fraction. Okay, good there? Any questions on that? Less people staring at like ghosts. Okay. All yours. Number 2. Go from beginning to end. I will not say the answer is 1/2. All right, let's go for it here. Again, if you need to label this, that's fine. And if you want to put it in the equation, that's fine. If you want to put it in the parentheses, that's fine. Eventually, you want to plug in the values. Those would be the plug-in values there. And subtracting.
Not 1/2.
Just 1/2.
I'm just kidding. It was on that one. So.
Oh, okay.
6 on top, 12 on the bottom, and reducing down to give you a 1/2. Okay, let's go to this one then. Let's connect the whole slope concept with the graph. And we're going to graph, remember the whole concept of intercepts? Let's do that as well. So if you have a y-intercept of 1, what point do you have? Where's that point here?
1 up.
Yeah, it's on the y-axis 1 up from 0, so about right there, right? Let me just jot this down real quickly here. Y-intercept is 2. Cool. And it's right there. Good there? That's what it means to have a y-intercept of 1. That means the line goes to that point. Good there? So again, trying to connect this whole concept of slope, intercepts, and graph. All right, whenever you're dealing with a slope, remember it's rise over run. Is that right? So it has to be a number on top as well as a number on the bottom. So if it's just 2, no, can't do that. Can't leave it as just a 2. So we make that into a fraction always. So now I have the rise and I have the run. So now let's connect this all together. If I know the y-intercept is here, I have a rise of 2. So that means I'm going to go 2 up, 1, 2, and I have a run, which means going horizontally 1. That means I go up 2 and I go 1 over here. There's my next point. Got a little bit to take in here. Let you guys sort of soak it in for just a little bit.
What does slope 2 mean?
That means for the y, the values go up 2, and the x values increase by 1. Or you have a.
Oh, okay. So when it says slope 2, that just means x is 2.
If you say slope 2, we change it into this right here first of all, because it has to be a rise over a run. And then the rise tells us what's the increase along the y-axis. And then the run tells us what's the increase along the x-axis. And then this point here also we need. So we really need an intercept and the slope. So our first dot, we figure out where the intercept is, because that's given right away. And then based upon that, now we go up. We change the y value by 2, and we change the x value by 1. So there's 1, 2, and then a 1. Once I do that, I'm good to go. There's my line. That's cool. So really, for a line, I either need 2 points for a line, or I need a point and a slope. Now produce a line for me. Okay, and then sometimes the slope sort of fails us. There's one particular time the slope fails. So let's take a look at that one as number 4. Can you calculate the slope here? All right, let's go for it here. So calculating the slope, y2 minus y1 over x2 minus x1. We're going to take the 11, looks like. Subtract negative 6 on top. We're going to take the 2, subtract the 2 on the bottom. And it looks like it's a 17 on top. But you got 2 subtract 2 on the bottom. You know, this the only time the slope fails is, remember, you cannot divide by 0. You can't have so many 0 pieces of something. Doesn't make sense. So 2 different answers here. You could say no slope. Online, when you go online, you're going to have to put D and E. Does not exist. Doesn't make sense to have that. Okay, another page you probably might be familiar with, should be familiar with, is page 211. This one has a little bit more information now than page 194. So there's a line through the origin again. There's a vertical line, and it shows that you have a no slope. The equation x-intercept is just the a value. So whenever you have a horizontal line, that means you have a slope of 0. You're not going up, not going down. You're just sort of flat. So page 211 probably be a good one to sort of refer back to, in case you need to sort of, as you're doing these here. All right, there's one question on the homework that slightly different than all these here, so I want to at least try it here. So I'm going to include an extra little number called number 5 on our matched problems here. Not little, it should be okay, just students got hung up on this one here previous semesters here. So a line, I want to find the slope of this line. What's the slope of this line? So I know a line has an x-intercept of 3 and has a y-intercept of -2. Can you find the slope of this line? And here's a little trick to it here. So if I say x-intercept of 3, what coordinates do I have? What's my coordinate? Where's the 0? Cool, yeah, it's a 3, 0 coordinate. I'm going over here. If I have a y-intercept of -2, what's the coordinate? 0, -2. Perfect. And then from here, now you can plug in the numbers you need here. All right, if you did it correctly, stayed ahead of me, you should get an answer of 2/3 if you finished it up. If not, let's do it together. So -2 goes in as your y2, and then we got this one is your y1. And back over here, x2, x coordinate of your second point, then x coordinate of your first point. So -2 subtract 0, that's just going to be -2. 0 subtract 3, change it to addition, put a little negative there, technically it's a -3, and the negatives cancel each other out, so positive 2/3 is your final answer. All right. Ooh, we're jamming. Okay. 3.6. Finally get to the last, really 3.6 is the last section where we learn something new about graphs here. We're going to switch gears a little bit for 3.7. But 3.6 finally gets to this final form, something called a slope-intercept form. And this is probably the fastest way we've learned how to graph. Want to get to the point of not having to write anything down whatsoever. Just look at some numbers, graph it, you're done. That's what this does. There's also another form, something called the point-slope form. So what's the difference between the two? You want to do it like this here. The slope-intercept form, we use that to graph the line. The point-slope form, we use that to get the equation. So it's almost like forwards and backwards. All right, let's work with the first equation, just sort of getting our mind wrapped around just the equation itself before we start graphing here. So y equals mx plus b. The m stands for the slope. The b is the y-intercept. And we have everything we need. Hey, remember that Remember, if we just knew the intercept and we knew the slope, that's all we need to graph the line. That's what we want to get to. Okay, so first of all, let's work with the equation here. If I know my slope is 1/2, my y-intercept is -1, can you give me the equation? What that describes there?
1/2 x minus 1.
Perfect, yep. It'd be y equals, and then the slope is the 1/2, so that means that's the number that comes in front of the x variable. The intercept is the one all the way at the end all by itself, so that means it's going to be a -1. Cool, okay, so we know the position there. Let's go with two graphs here as we do it together here. So we're going to find the equation first real quick here, set up the equation, and from the equation let's graph this line. Alright, so find the equation first. So y equals, just like we did for number 1, slope is a -1/3, therefore -1/3 goes right in front of the x variable. The y-intercept is 2, it's a +2, so let's put +2 right at the end. So just bringing out each of those pieces. Or how do we graph it? Well, let's just like we did on last section here, we take the y-intercept first, this guy over here, this little 2. And we're going to find 2 along the y-axis here, so about right there. Alright, -1/3. Ooh, there's a negative there, so careful. Remember, this is the change in the y values. But in this case, it's a -1, so instead of going up, it's going to go down this time. And then we're going to go 3 across. So from this point, how about down 1? And 1, 2, 3 all the way across right here. Okay, good. The interesting thing about slope is because it stays constant, right? I could keep on going like that. So if I went down 1, 3 to the right, I could go down 1, 3 to the right again. So notice these lines are, they're collinear, aren't they? So if you want to make sure the line has more detail on it, you can just sort of keep on moving that slope over each time. Okay, and then something else I want to bring up here, tell me if you guys agree or disagree, is -1/3 the same thing as 1 over -3? Is this a true statement or a false statement? How many say, Mr. H? That's a true statement, Mr. H.
Oh yeah, it is true.
4, okay. I'm saying, Mr. H, that's a false statement, Mr. H. That's 1, 2. That's only 6 people voting. You guys can't abstain. That's not cool.
Doesn't the negative sign always have to be at one number, not like in the middle of it?
The negative sign, it doesn't matter where it's at. We prefer it to be on top, but could be on the bottom, could be in front, could be one of the 3 places here. But is -1/3 the same thing as 1 over -3? Absolutely, yes it is, and this little slope proves it here. So remember, this one tells you have to go down 1, 3 to the right. This one we would say we have to go up 1, is that right? But then we go 3 to the left. Let's see if it's going to still stay collinear even in that, okay? So from this dot, how about we go up 1 and 1, 2, 3. Hey, still collinear? Still lands on the line. I can keep on going that. Up 1, 1, 2, 3. Still collinear. Cool. So again, just a little bit of a proof that that's still the preference is you put it on top, but the number's still the same across the same. Okay, anyways, connect them with the straight line, arrows at the end. We have graphed line without really writing anything down. Sure beats 3.1 or 3.3 when we were plugging in a value, doing some algebra, finding the other value. Okay, sometimes the equations are not set up just like this. Number 3, sometimes they're set up like this, negative 3x plus y equals 6. So they tell us to find the slope first and then the y-intercept. Well, the only I can do that only if it's already solved for y. So I'd have to solve this for y to give a slope and y-intercept. So in this case, I'm going to have to solve for y by adding 3x to both sides. Y equals, let's say 3x plus 6. All right, m value, what do you guys say? Three, okay. And then the b value, which is the y-intercept, is 6. Yep, and the only thing is whenever we're graphing, whenever you just want to know what is the slope and the y-intercept, this is the correct way to say it. But if it says for you to graph the line, then the slope changes a little bit here because we want to know rise and run. Good there. So we put a little 1 underneath there sometimes. All right, based upon the m and the b, can you graph this line? Kind of careful here because it goes out to 10. So that means each of those is 2.
What does the B stand for again?
B is the y-intercept.
Oh, why is it a B? Instead of a Y. Does it matter?
Because it's not real. All right, so let's go for it. So b is equal to 6. That means that is the y-intercept, and this is 2, 4, 6. It has to be right there. Then from here, kind of careful here, we're going to go up 3 and 1 to the right. So from this 1, 2, 3 up to 9. And then we're going to move over 1. It's almost like really in the dead center. If you're doing the match problems, you should put it in the dead center of that square. If you just wrote out your own graph, then you could put it anywhere. All right, connect a straight line, and good to go. All right, sometimes we don't even want to graph. Sometimes all we just need to do is to figure out what my slope or y-intercept are, and that's it. So for number 4, no need to graph it, but can you solve for y, and then just state what is the slope, state what is the y-intercept. All right, hopefully you've done it already here. So in order to solve for y, you would have to subtract 6x from both sides. And then what we want to do is we want to keep it the same form. So we want to do the one with the x first and then the number by itself at the end here. So negative 6 goes first, the 15 at the end, divided by 5 everywhere. And how about a negative 6/5 x plus 5 goes into 15 3 times. Perfect. And on these ones, you don't want to write out slope, S-L-O-P-E. Might as well just put m. M equals negative 6/5, b equals 3. Cool, and that's it for that. Let's go backwards now. So we learned how to graph, we learned the whole concept of slope and the y-intercept, how they all fit together. Let's go backwards. Let's say you are looking at a line. You want the equation of a line and you somehow figure out the slope of it. So pretend you start looking at a graph, you're like, hey, you know what? Look, there's a slope of -1/2. And then for sure it goes through 5, -4. And that's all we pretty much know. Can we figure out the equation of this line? That's what we want to get to eventually. Well, you can't use y equals mx plus b because we know the slope is the m, but we don't know what the b value is. So we're going to get stuck. So the formula that we use is the point slope form right here. And this, again, this takes you from graph back to an equation. All the time. And I added some extra problems here. I didn't think that was sort of sufficient enough problems here to work with this here, so I kind of put in extra problems here. So how do we do this? The m is still here. That's cool. So -1/2 is going to go in for the m. But notice real quickly here before we do anything, notice you have a y and then a y1. So this y is the variable. This is the point you plug in. So again, same thing of x and x1. The x by itself, that's the variable x. The x1 is the coordinate x that we plug in. So let's go for it here. So we're going to rewrite the problem. Y. Oh, okay. Minus. And then when we look over here to my y coordinate, I have a -4. So really subtracting a -4, isn't that really adding +4?
Yeah.
So let's plug that in already here. So if you're subtracting -4, just bring it in as a +4. Okay, slope is -1/2. That's easy enough. Parentheses open up. And I have x subtract whatever x1 would be. 5 is good. Closing it off. There's my equation in its form. But normally what happens here is we want to solve it for y. So we're going to do 2 steps always to solve it. Distribute the slope. -1/2 times x, -1/2 x. Negative times a negative is a positive. Whew, anybody? 1/2 times 5. Michael, is that good right there? Technically, we could make this 5 into a 5/1, so it's a 1 and a 5 multiplying together, and a 2 and a 1, so 5/2. Still not done, because we're not solved for y. What should we do next? Yeah, subtract 4 from both sides. Okay, now that's not fun. Because the slope is still okay. That's good and go, but we got to do all this right here. 5/2 subtract 4.
Is it -3 over 2?
I think so. Let's see. Let's do this here. Let's set it up. 5/2 subtract 4. In this case, we're going to put a little 1 underneath the 4. Get some common denominators here, which would be a 2. So 5 stays, but the 4 changes into an 8. And let me just slow down right here real quick here. And I'm going to change the subtraction because I like subtraction. I'd rather add the opposite. So -3, so -3 over 2, so -3/2. And again, I don't need to change it to a mixed number because I'm not graphing it. I keep it as just 3 over 2 is fine. If I was graphing it, then I'll probably have to change it to mixed number to figure out where it's at. Okay, let's do a slightly more easy problem than this, just because of less fractions here, just for you guys to get used to the pattern that we're using. So here's our formula. Plug in the slope, plug in the point, and then we distribute the slope, move everything over, solve for y. So this one I just took as number 19 from the homework here. Number 19, I have a point of -2, -5. M is equal to 2. So can you solve this? Can you write the equation for this?
Oh.
Same thing that we did for the previous problem. I'll even give you the formula that to use here. Y minus y1 is equal to x, or m times x minus x1. Alright, let's go for it. Plug in stuff in. So y, again, minus a negative 5, just put plus 5, equal to a slope comes in as 2, and x subtract a negative 2 would become a plus 2. There's my plug in into the formula. Now to solve for y here, distribute this little 2 to the x, 2 to the 2, so y plus 5 stays, but 2 times x, and 2 times 2 is 4. At this point, one little step left here, subtract 5 from both sides, and we get y equals 2x minus 1. And I think we've seen a formula like that before, right? 2x minus 1. I think we graphed that even before, sometime earlier. But there it is. Awesome. Got the equation. And if I were to sort of pretended that I looked at a graph and I figured out that the slope was 2 and I figured out that it went through that point there, I got it. Okay, sometimes though, here's my little problem. Sometimes we actually don't know the slope. Sometimes we look at a graph and I can kind of figure out, I know it goes through this point, and it goes through another point, but that's about it. So this is what number 6 is about. So I looked at a graph, I say, you know what, I know it goes through 5, 1 because it's right on 5, 1. I know it goes through negative 2, negative 2, but that's all I can sort of figure out. Alright, I want to use this formula, but I can't because this says I need to know my slope first before I can use this formula. Hey, you know what though? Don't we have actually a slope formula like this? And since I have 2 points, can I figure out the slope on the side?
Oh yeah.
Cool, okay, let's figure out the slope first and then we're going to plug in that number in. Cool. Alright, so go for it. So looking at this here, what did you guys get for slope?
Positive 3 over 7.
I go with that. Positive 3 over 7?
Yes.
Okay, we're going to use that slope against a fraction. We're going to finally plug it in, except the only thing is, look at that. You know that y1, x1? We actually don't have 1 point, we have 2 points. Which one should I use? Yeah, it doesn't matter. Both of them are on the line, right? Somewhere along the line? So it doesn't matter which point I choose here. So y minus, and I just chose the 5, 1, just so I don't have to mess with the negatives there. 3/7 goes in for the m, and x minus 5. Good there? If you choose -2, -2, that would be okay as well.
So you don't actually have to use y1. It could just be either of the y's.
Mm.
You still get the same answer, right?
Cool, yep. And the question comes up is, if I chose -2 as a point, would I get the same answer? Absolutely. Once you solve for y, when you say y equals, it'll give you the same exact answer. Because they're both on the same line. So since they're both on the same line, no matter what point you choose, they're going to give you the same answer. Alright, so got a bit of work here with my fraction here. So 3/7 times x, 3/7 x. 3/7 times a -5.
5 over 7, -5 over 7, which then turns into 15.
Yep, I'll go with that. 15 over 7. The 3 and the 5 multiply together. And since the 5 is just a 5 over 1, 1 and 7 make a 7. And then we have to add that little 1 to the other side. So on the side if you need to here. Got almost done except for the last part here. -15/7 subtract or add 1. You know, 1 is going to be 1 over 1, right? 1 you can change it to whatever you like, right? In this case we want to change it to 7 over 7. So 1 changes into whatever number as long as the number on top and bottom are exactly the same. So when you add these guys up, you still get a -8 on the top, so that's okay. -8/7 as our final answer there. Okay, a whole bunch of fractions here. I want you to try it yourself here. So again, chose another homework question. I think this is actually part of your homework here. Number 29, I think, is part of your homework. Alright, can you find the equation of the line that passes through these 2 points? Just like on the previous slide. Alright, again, the equation we want to use, but we can't, is right here. So then we have to move off and find the slope first. Hopefully you did something like that already here. 1 subtract a -5. And again, adding 5 instead makes a 6. And then 2 plus 1 makes a 3, so I got a slope of 2. Once I get that, and again, doesn't matter which point you choose here. I'm going to choose 2, 1 to work with, as opposed to -1, -5. Again, still get the same thing here, no matter which one you choose. Distributing the 2 to both the x and the -2 makes 2x minus 4, adding 1, and we wind up with y equals 2x minus 3. Okay, good there. One more other type, again on the homework here, but I figured we should try it here, is number 42. Again, this is just from the textbook here. Can you do the same thing here with this one? Find the equation of a line that passes, that has an x-intercept of 2 and a y-intercept of 3. Alright, I guess we should get something here. If it's an x-intercept, we know it has to be 2, 0 for the coordinate. If it's a y-intercept, it has to be a 0, 3. Once you got that concept, I think the rest is pretty easy, because then it's just like the previous example here again. That's the formula I can't use yet because I don't know the slope. So I go and find the slope. So y2 minus y1, 3 minus 0. x2 minus x1 is 0 minus 2. And on top, it will be a 3. On the bottom, -2. And again, moving that negative in front or on top gives you -3/2 as your slope. and then it doesn't matter which one you choose here. As again, I'm going to choose, looks like the 2, 0. No, so x minus 2 inside the parenthesis. So y minus 0 is just a y, that's great. Distributing the negative 3/2 over negative 3/2 x. And how about a plus sign here? Let's see, 3/2 times 2. The first one becomes plus plus, yep, and this point, how about a 2 and 2 reduce? So how about just a regular 3? Let's see, or here's a little tricky part. See if you guys are paying attention here. We have our slope, don't we? Do we also know what the y-intercept is? Hey, so in this case, could we have just plugged straight into this? Yep, we could, right? Slope is negative 3/2. And the b value is the 3. And done. Right, because we had all the information for y equals mx plus b. Haha. All right. I think in the remaining time, I think we can still do this here. 3.7. Covered a lot of ground today here. Yeah, let's do this here before we get to break here. And then at break, then we can take a little bit of a time off here. So we're going to change gears just a little bit here. So no more equal signs. What we have on our hands is these inequalities. So just like we did at the end of chapter 2, remember that? We did inequalities end of chapter 2. Same thing here, but now how do we do it with there's x's and y's at the same time? So I have the less than symbol, less than or equal to. I got the greater than symbol, I got greater than equal to. These are some examples. Stuff that looks like this. Well, we got one little small problem. Remember how we did bracket or parenthesis, meaning that you included that number right at the end or you didn't, right? So if it was a parenthesis, that means we didn't include it. And if it was a bracket, that means we did include it. With the lines now we have a different problem, because now we're graphing a line. How do you differentiate whether we want the stuff that's on the line or we don't want the stuff on the line? Okay, so this is this little bottom section right here. So if we have a less than or equal to symbol, or if we have a greater than or equal to symbol, that little equal to means I want the stuff that's actually on the line. The way we show that is we draw ourselves a solid line, just like we did before. Just like we did before with equal signs. Right, no change there. But if we don't want the stuff on the line, if it's a less than symbol or it's a greater than symbol, that means we don't want the things on line. We don't want the end point. We don't want the stuff at the end. So your book calls it a broken line. All the other math textbooks call it a dashed line. So there's the distinction there. So solid line between or a broken line. And really the rest of it is going to be graphed as we did before, except for this little distinction. And then extra little thing called a shade. So we'll see what that means. So let's go for it. I think as we do some examples here, it'll be more clear. So let's graph the solution set x minus y less than or equal to 1/2. Alright, since the x's and y's are both on the same side, I'm going to do this by intercepts. The only problem we have is we have never graphed stuff with inequalities with this little symbol here. Stuff that we've used before are with equal signs. So we're going to go back and sort of solve this using just this right here. we're going to at least get the line itself. And once we get the line, then we're going to think about what we want to do with it. And of course, there's fractions here already. So let's go for it here. So if x becomes a 0, what is y going to become? There you go. That'll work here. Divide through by negative, and it makes a -1/2. Okay, then we go the other way around. And again, we're just doing intercepts just like we did before, right? No changes. Plug in a 0 in for the y value. What's the x going to be? Yep, that will produce a 0 with next to the y value, and we get x equals a +1/2. Cool. Just like we did before, let's graph it. Let's graph 0, -1/2, which is between 0 and 1, or -1. Between, and then the graphing 1/2 0 is going to be between 0 and 1 over here. So now we think about, okay, we graph the 2 points. Now think about the line itself. Now, do we want a solid line or a dashed line? Do we want the stuff on the line or no? Yeah, solid line, because this will equal 2 part. Perfect. And now let's talk about it. Now we also want the stuff either this side of the line or this side of the line, because of the inequality. Inequality says there's stuff to the side of the line as well that we want. So we got to figure out this. We got to figure which one is the side where we need the shade at to be, and the shade that we want is the one that fulfills this inequality, because we're still looking for solutions. We good? So we're going to pick a test point somewhere that's not on this line. Anywhere, 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 as long as it's not on the line. And the best one to pick, still 0, 0. Now, could you pick? Can you pick 5, 5? Sure, you can. Yeah, you pick any number you like, as long as the number is not on this line. But if it doesn't go through 0, 0, that's such an easy one to pick, because I don't have to do much work. So we call it a test point. We're going to test 0, 0. And the question that we want to know is it true or false? Plug a 0 in for the x, 0 in for the y, and becomes 0 is less than or equal to 1/2. True or false?
True.
Hey, that's a true statement. Okay, so here's what we know. We know that any number this side of the line, anything that also is on the side with the 0, 0 is true as well. So -1 would be true. 0, 5 would be true. Any number here would be true. So what we do is we just shade this whole entire area. So we're saying all the stuff to it is on the line and in the shade. Alright, so if I picked another point in here, it would be all true. If I picked a point on this side, it would be all false. And if you want to, we can try some. But really, 4, 1 right here would be 4 subtract 1 would be a 3, and 3 is not less than or equal to 1/2. So that's a false statement. In fact, any point I choose here, these guys will all be false statements here. Any points that I choose here would be all true. So let's take a look at this one. This would be what, 5, 1? Or sorry, 1, 5, right? So 1 subtract 5 is a -4, and is -4 less than or equal to 1/2? Sure is. Okay, so all these points here, those will all be true points. Okay, we're good there?
So if the line does lie on the origin, then we can't use 0, 0?
Correct, yeah, you gotta just choose some other point. Even like this one right here, like 4, 1 or 5, 5 or any other point. Okay, we're good there? And this really tells us that instead of just having something on the line, it could be on the line or on the side. I guess maybe a good illustration would be something like a nuclear submarine. when the temperature, you don't want the temperature to go beyond a certain melting point. And so if the temperature gets hotter and hotter and hotter, that's not a good thing. But if the temperature is 38, still okay. Temperature is 120, still okay. Once it gets to 168, now we're in trouble. We're good. All this underneath stuff was okay until we got to that point. Same thing happened in Japan, right? The reactors got a little bit too hot. Then we're in trouble because now you got melting metal. Now you got lots of problems. So this really defines, and it's really on the border of two different variables at the same time. So you're looking at two different items, or the interaction between two different things at the same time. All right, we'll go see if we can make it before break here. So let's graph this one. Now notice this one is set up kind of like y equals mx plus b. Notice the y is by itself on one side. All right, so in this case, we're going to think about it being like this. We're going to think of it as having an equal to symbol. So now the question is, can we at least put the two dots where we need them based upon that information right here? The first dot's going to go at 7, right? Because that's the y-intercept. So this goes by 2s, though. So 2, 4, 6, 7 would be about right there. And from that dot, we got a slope of 1/2. So that means rise of 1 and then 2 to the right, or 2 for the run. So up 1 and 1, 2. How about, is here okay for the next dot? I'll let you guys catch up here a little bit here. Ask me the questions if you need to.
Okay, so you went up to the 7 and then you went up 1/2?
So I went up 1 and then I went 2 to the right because it's rise over run.
That's right.
So this controls the y values, this controls the x values.
Okay, yeah, I wasn't paying attention to
Cool.
the 10s.
Good. Okay, solid line or dashed line? Ooh, this one's a dashed line because of the less than symbol here. So in this case, just a dashed line coming across. Some people now using their erasers to make it into a dashed line. That's okay too. Okay, so now the question is, I actually don't want the stuff on the line. Is my final answer? My final answer is stuff that's not on this line. So I only want the stuff in the shade, but which way does the shade go? We gotta pick a test point. Which one should we use? I like 0 there. Cool. Okay. Test it and tell me true or false, and then shade in the correct area. Alright, and I heard true, is that right? Since this was true, we're going to shade everything towards the 0, 0 and beyond. So how about something that looks like that? Okay, so let me go back, just to sort of for us to see it here. So for number 1, we did this by intercepts. And the reason for it is because x and y was both on the same side. It's somewhat a lot easier just to do it that way and be done. This one we did it by y equals mx plus b, using the y-intercept and the slope. Because once we got that, we tested the shade and we're done. Cool. Alright, the reason why we did it this way because this y is already solved for. But you could also change, again, let me just kind of bounce between the two. We could also solve this for y as well, right? So it kind of just depends which way you want to do it, which way you're more comfortable with. Is it the slope, the intercept method, or the y equals mx plus b? So I'll let you guys try this one by yourself all the way through from beginning to end. Whether you want to use the intercept method here, that's perfectly fine, or the slope actually, now that I'm thinking about this here, you guys can't use the intercept method, because if you plug a 0 for the y, then x is equal to 10, and 10 is not even on the chart. Ooh, bummer. Okay, we have to solve this guy for y. So let me set it up first. Let me put a little equal to instead of a greater than. Solve this for y. Find the slope and the y-intercept and graph it. I'll give you guys a couple minutes here. Try it yourself. Alright, let me start it as well here. So hopefully subtracted x's from both sides and hopefully divided by 5 on both sides. And here's what you got for your equation. And again, the whole point here is just to get those 2 dots that we need. So starting at the y-intercept is 2, so along the y-axis, found my 2. A negative 1/5 is the slope, so that means my change in the y values is a negative 1, change in the x's is 5, so I'm going to go down 1 for the y, and across over here to get to the 5 for the x change. Solid or dashed line? Solid line because of the equal to part, and probably to the test point already, and you probably chose 0, 0. You guys have been taught well, probably, that's why. Okay, and again, the reason why I like 0, 0, because the whole entire right hand side, if x and y's are both on there, that just becomes 0. No need to calculate anything. So you're just really thinking, is 0 greater than or equal to 10? No, I don't think so. Okay, that's a false statement. Therefore the shade should be towards the top. Alright, show of hands how many got that correct all the way through before I show the answer. 2, 3, 4, 5. Cool. Okay, and last problem. You graph from this. Y is greater than negative 1. Alright, immediately you should recognize, oh, Mr. H, you know what? Since there's a y there, isn't that a horizontal line? Is that right? So then there's no x here. Again, that's where that little page helps you. That's probably what should be on your 3x5 card somewhere. Solid or dashed? It's a dashed line. So horizontal line coming across. Again, like that. And then, of course, we still have a test point here. This one, if you think about it real quick here, let's stop here. The y values has to be greater than negative 1. So think about it real quick here. All the y values that you think about, when are they greater than negative 1? Here, or are they greater than negative 1 here? Yeah, they go above, right? Because this is 0, 0, right? This is like 0, 5. 5 is the y value, right? So it's really... You're talking about the y values. The y values are bigger than negative 1 anytime you go higher than this, because the y values determine the vertical aspect of a graph here. But to test it, 0, 0 is good. There's no x to plug in whatsoever, so there's only a little y to plug in that's it. So 0 is greater than -1, obviously, so therefore let's shade anything above that line there.
Okay, so when there's no x, it's always 0.
I just plugged in 0, 0. It didn't matter which one you plug in, but there's no x to plug in whatsoever in the first place, so we forget about this guy.
Mm-hmm.
We just plug in for the variable that's there, so in this case it's the y
Oh.
to plug in.